Hello learners, welcome to today's discussion. Today we are going to go through a topic in Form 4 under the rates of reactions. Rates of reactions. In this case, we know when we are talking about rates of reaction, we are looking at the speed at which a chemical reaction takes place. The question we have reads, the sketch graph below shows volume of carbon 4 oxide evolved in a reaction between marble chips and dilute hydrochloric acid against time. We should know that marble chips is simply calcium carbonate. On the same grid, sketch the curve for volume of carbon 4 oxide if powdered calcium carbonate was used instead of marble chips. Remember, powdered calcium carbonate increases the surface area of contact with dilute hydrochloric acid, and therefore the reaction is going to be faster. Hence, it will take a shorter time for it to come to a completion. And in this case, that curve is going to simply come this way, then leveled at this particular point, meaning if you measure the time taken here, it will be less than the one taken by the other curve where we have used marble chips. So by so doing, you score that one mark for sketching the graph for powdered calcium carbonate. That one has been done. Why is dilute sulfuric acid not used in place of dilute hydrochloric acid? This is because calcium carbonate will react with dilute sulfuric acid to form calcium sulfate, which is insoluble. So we can say that sulfuric acid reacts with calcium carbonate, to form insoluble calcium sulfate, coating, which prevents any further reaction, between the acid and the carbonate. That means literally that particular reaction will stop. We move down. Explain why carbon 4 oxide is more suitable in extinguishing petrol flame than water. Remember, if you look at water and petrol is less dense and therefore it floats on water and continues to burn. But why is it that carbon 4 oxide is more suitable? The reason is very simple. One, carbon 4 oxide is non-flammable. And has a high density, thus prevents the air from getting to the burning fire. In other words, it forms a blanket and therefore cuts the oxygen supply and therefore stopping the fire from burning. We move down. X grams of anhydrous sodium carbonate reacted completely with 30 centimeter cubic of dilute hydrochloric acid to produce 672 centimeter cubic of carbon 4 oxide at standard temperature and pressure. And at this particular condition, 1 mole of a gas occupies 22,400 centimeter cubic. The first part of that question, write an equation for the reaction. This is a reaction between sodium carbonate, a solid, and a dilute hydrochloric acid. And this reaction produces sodium chloride. It produces carbon 4 oxide plus, of course, water. Remember, water is a liquid. We can balance this equation by writing 2 behind hydrochloric acid and a 2 behind sodium chloride for that equation to be balanced. Roman 2, calculate the concentration of the acid in moles per liter. 1, since we know the volume of carbon 4 oxide produced, the volume of carbon 4 oxide was 672 centimeter cubic. We can get the moles of carbon 4 oxide and use it to get the moles of the acid. So moles of carbon 4 oxide, first, we know that 1 mole of a gas occupies 22,400 centimeter cubic. 672 centimeter cubic will occupy how many moles? In this case, if you cross multiply, we are going to have 672 times 1. You divide by 22,400, and this one is going to give us 0.03 moles. These are the moles of carbon 4 oxide, but if you look at the mole ratio of the acid to that of carbon 4 oxide, you realize the moles of the acid are twice of carbon 4 oxide, and therefore moles of HCl will be equal to 0.03. You multiply by 2, which gives us 0.06 moles. We know that this number of moles were contained in 30 centimeter cubic, but we need to calculate the number of moles which are in 1 liter. And therefore, in this case now, we are going to say 0.06 moles are in 30 centimeter cubic. In 1 liter, which is 1,000 centimeter cubic, how many moles are we going to have? If we cross multiply, we are going to have 0.06 times 1,000, everything divided by 30, which is going to give us 2 moles or 2 molar as the concentration of the acid in moles per liter. Next, Roman 3, calculate the value of X, and we are told X grams of anhydrous sodium carbonate. In this case now we need to get the moles of the carbonate. This is Roman 3. Moles of the carbonate. We know the ratio of the carbonate to the ratio of carbon 4 oxide is 1 to 1, and therefore, since the mole ratio is 1 to 1, the number of moles of the carbonate are going to remain 0.03. And we know, since we have the number of moles, we can get the relative formula mass of sodium carbonate. We know that sodium has a relative atomic mass of, let me do it here. Sodium has a relative atomic mass of 23. So if you take 23, you multiply by 2, you get 46. Plus carbon has 12. Oxygen has 16. You multiply by 3, you get 48. And the total is going to be 106 grams. And for us to get now the mass, we take the relative formula mass, which is 106. You multiply by the moles 0.03, which is going to give us 3.18 grams as the mass of the carbonate that reacted with the acid. Rainwater, that is part C. Rainwater falling and running over calcium salt rocks become hard. What is hardness of water? We know water hardness is caused by the dissolved calcium and magnesium, and therefore we can say water hardness is the amount of dissolved calcium and magnesium in water. Remember, when calcium and magnesium are present in water, that water is said to be hard. Roman 2 of the same question, explain how sodium carbonate can be used to soften water. Use ionic equation. Remember, water hardness can be caused by calcium ions. This is the water that contains calcium. We add sodium carbonate. From sodium carbonate, we need the carbonate ions. And this reaction will produce an insoluble calcium carbonate, which precipitates out. Equally, we can also use magnesium ions, aqueous. Aqueous means this is water containing magnesium. We are adding sodium carbonate. Remember, in sodium carbonate, we need the carbonate ions. And this one is going to give us magnesium carbonate, which is a precipitate or which precipitates out. Thank you for watching and welcome to the channel.